Hello everyone, in this session I will share how to design a malware anti-copy design that can fully prevent reversing engineering by researchers. And I'm Sheng-Hao, currently work at TX1 Networks. I love Intel assembly, vulnerability, and attack technique, and I have 10 years experience of reversing engineering. And I just wrote a book, Windows Active Warfare, recodes all the attack technique used by the cyber army. And here's today's outline. At first, most computers today are equipped with antivirus. So we will first discuss the design of antivirus and the challenges faced by the attackers. Next, we will talk about create process X, an API left over from Windows XP, and how it can be used to bypass antivirus scanning at the kernel level. This technique has become into a lot of attack techniques, such as process doppelgangling and herpetaping. Then we will discuss the NTFS flow. Attacker can use it to bypass the Windows file lock to delete any file, even a running program. And finally, summing up all the tricks, attacker can design a malware protection that prevents any copy and makes it impossible for antivirus protection to send back malware sample for researcher to analyze. First chapter, antivirus design and the challenge we met. Most people must have this kind of experience seeing strange program running in your computer. Then manually upload the program file to VirusTotal or security vendors to verify that it's a malware and confirm your computer is safe or not. The security vendors has designed antivirus product to automatically scan computer for running malware and send it back to the researcher for analysis and remove it. To design a good security product, all three issues must be considered. How to identify malware, when to scan, and how to send back those samples. So, therefore, on the flip side, hackers have the same three headaches when attacking computer with antivirus. So, first question, is that possible for attacker to inject their malware into a trust system process without trigger endpoint detection? And yes, of course, the next question comes up. Our payload should not be scanned during ingestion. And the final question is, if unfortunately our backdoor is sent back to the security vendor, can we totally stop the researcher from cracking it? In this talk, we will break these three challenges one by one and eventually design a DRM protection against antivirus submission our sample. Before all the attack details, I would like to mention that Windows XP leaves behind an API that is extremely powerful for attackers create process X. As everyone knows, if a user clicks an executable file, File Explorer uses the API create process W to execute the program file. And this API internally uses create process internal W to do the rest job and launch the child process. And first, use fopen to open the program file and use NT-create session to create this file as an image session. Then use anti-create-process-x to create this imagination as a new process which currently only has this program module loaded in memory. Now we have a single process with no thread but with the program module loaded. Then we can create a PEB structure for this process, which is used to record environment information. In addition, we can manually write a lot of information in this structure, such as the path of the process and working dictionary and string commands. And finally, we can use anti-create-thread-x to create a thread for this process, and this process will run normally. And I have released a project on GitHub to do the details above, so if you are interested, you can download it and play with it. And in this trick, we just mentioned we have the ability to hand fill the path of a process in the PEB structure, right? So the most fun part is if we run the malware and fill in the process path as a trusted system service, and use a scanning tool to check this process, you will be surprised that it looks like have system service signature. Wait a minute, you might ask, what about antivirus? When exactly was the antivirus do the scanning, right? So it's about the time to say the real-time scanning of antivirus and how it works. Microsoft provides security vendors with the ability to install callbacks. They will be invoked when the creation of process or thread on the system. And Java developer can use this API to receive such event. So you can say that the hook is installed in the kernel level, and surely it's not easy to unhook bypass for attackers. Then you might ask, when the malware is running, what information can the kernel receive? The kernel receives a create notify info structure. They contain information about the newly created process, which can be used by antivirus to scan this process. This structure contains file object, image file name, and command line, totally 3 data that will be scanned by antivirus. The last two can be easily forged. However, the first one, file object, is the file we opened by fopen and cannot be forged easily. As a result, most antivirus only scan this file object for malware. As I mentioned earlier, once a process is created, the kernel will immediately receive an event about the new process, right? So when does the kernel actually receive this event? As you can immediately guess, when the API for creating a process is called, right? For example, create a process W, create a process internal W, or anti-create process X, right? These 3 API. But in reality, the kernel only be notified when the first thread of the process is created. So when the first thread is created, antivirus is notified to scan the program file for this process. These issues allows attackers to use it to bypass antivirus scanning. How? So there is an attack method. First, attacker can create a dummy file. And second, attacker can write malware payload into this file and use anti-create process to create this file as a process. Still remember this file is created by attacker, right? So we can overwrite it with the useless data. This makes it look innocent. Then we can create the first thread for this process, and the malware got invoked and run. And you might ask about antivirus. At the same time, antivirus will be notified to analyze the dummy file. Since the file has been written as a useless data, so this file evades the virus scanning. I also create another project to reproduce this technique, mini happening. This technique is also able to discuss the malware as a side service. And this attack method and the antivirus vulnerability was first introduced in Black Hat Europe 2017. But in 2021, this trick can already be detected by Windows Defender. Once we try to write malware into a file, antivirus can scan it with mini filter. So a new question comes up. Can we control a file data as malware, but without actually writing anything into this file? As we mentioned before, the issue of antivirus scan timing. Then we will talk about how to design a malware launcher that can easily evade antivirus scan and create any malware as a fileless process. It's similar to the previous trick. First, attacker can create a dummy file, then use API set file information by handle to mark this file as a delete unclosed temporary file. Because we are opening the temp file, in the meantime, there's no one can open this file and read it, including antivirus and defender. This ensures that no one can scan whatever we write into this file. Then we can use anti-create process X to create this file as a single process. Remember that this file is a delete unclosed temporary file, right? So once we close this file, and it will disappear completely from the file system. And we can create a PEB structure and thread for this process. This malware process will run as a fileless process. Right now, antivirus try to scan this process since the file of this process have been deleted. So antivirus got nothing to scan. So far, I prepared a demo video to show the power of this technique. And you can see here, I enable the real-time protection on the victim and try to invoke mimicize on the victim. And you can see mimicize got detected by defender and got removed. And I try to use my tool, mini ghosting, to launch the mimicize on the victim. And we use this tool, process ghosting, to launch mitigation as a fileless process. And you can see in the task manager, that is a process with no name and no path. Even we cannot to open this file location. It's cruel, right? Next, we will discuss if malware can make itself fileless without any launcher. Here, we are going to talk about the file system exploit. As we all know, if we download a file from the networks, the Windows operation system will create a string in this file called zone identifier, which records the download source and the website in text form. And there are many attackers in the wild write their malware payload into a hidden string of innocent file. This will allow malware file to be hidden in the file system. And the most interesting part is those malware runs as a process from the hidden string. Even the process is still running, but the innocent file can be deleted anyway. So this trick was discovered by Jonas. We can open any exe file with a delete flag and relocate the physical data of the exe file to another useless string. Then this program file can be deleted no matter this program is running or not. Therefore, for attackers can design a special malware to run on the victim. Then use set information by handle this API to relocate current file data into another string, then close it. Right now, the file already unlocked. Then we can delete it even if the malware process is still running, or we can overwrite the malware file data to a service program so that malware process will look it was signed by Microsoft. So here's a video demo to show the power of this technique. And here you can see I designed a tool is Skrull, and here is a pickable, a malware pickable. And you can see here, this malware have no signature here. And I'm running this malware. So this malware is running now, and I can use my tool, Skrull, to give this malware a signature. And you can see here now, pickable, this malware got no signature, but right now, pickable restart and have the signature now and signed by Microsoft. Let's put it all together and design a malware DRM. I call it Skrull. Nowadays, all the antivirus must be equipped with the feature auto sample submission for monitoring those malware in the wild. Therefore, can we design a DRM to protect our malware sample? Yes, we can. As soon as the malware is submitted back to the security vendors, it will naturally broken, and researchers cannot do study on our malware sample. So I designed Skrull DRM, which is a malware launcher to prevent sample submission. You can use this tool to generate and launcher. Use this launcher to run your malware. This launcher will do process ghosting to execute the malware sample and bypass antivirus scanning at the same time. Also, the launcher will grab unique information about this victim, such as username, CPU count, and system version, and use this unique information to rebuild itself. So, in a real attack, a hacker can drop a launcher on the victim's computer, which contains an encrypted malware payload, and next, the launcher will rebuild itself with the victim's feature. Then, the launcher decrypts the malware in the memory and bypass the antivirus with the process ghosting method, and run the malware as a fileless process. Finally, whenever antivirus want to send the launcher back, because the researcher do not have unique information about this victim, so the launcher will naturally destroy it. This ensures that researcher cannot study on it at all. So I prepared the last video demo to show the power of malware DRM. And here you can see the left side here is attacker's computer and the right side is victim's computer. And you can use Skrull, this tool, to build mitigation or your malware a launcher. And this launcher can drop this launcher to victim. And you can see here I enable the real-time protection on the victim and try to run mitigation on the victim, and it fails. But we use our launcher to launch our mitigation malware. You can see it successful run the malware, and if anyone try to send the launcher back to his computer and do analyze, the malware will naturally broken if it got sent back or copied. Conclusion: for attackers, we can abuse template file to create a process they will not be scanned by antivirus real-time scan. Also, by moving the data to another different string, we can delete a running program file. Finally, using the self-deletion technique, any malware can rebuild itself on the victim side and do marking signature. We also want to remind security vendors they should not scan the file only on the file system, but also do analyze those running process. Thanks for listening. If anyone have any question, it's my pleasure to answer, and please contact me by mail, Twitter, or Facebook. Thank you all.